Okay, let's take a look at some of the homework problems that are in section 13-3. Like problem number 1, in a right triangle, find the length of the side not given. Now we're told that the length of A is 9 and the length of C is 15. Now C is the hypotenuse, which is of course the longest side of this right triangle, and one of the legs is A, that's 9. Now B is not given. That's what we're trying to find. So here we have to use the formula for the Pythagorean Theorem, which is in this case is going to be a squared plus b squared is equal to c squared. Now a is given as 9, so we'll have 9 squared plus b is what we're trying to find, so it'll be b squared is equal to c, which is 15, so it'll be 15 squared. Now 9 squared is 81 plus b squared is equal to 15 squared, that's 225. Now to get b squared by itself, we need to subtract 81 on both sides to get b squared is equal to 144. Now to find out what the length of b is, the opposite of squaring something will be taking the square root. So we have to take the square root of 144 to get 12, which is what the length of b is going to be here. So here, the length of that third side is 12. All right, problem number 2. Determine whether the given numbers represent the lengths of the sides of a right triangle. And you have the lengths 11, 14, and 17. In this case, I'm going to let A be 11 and B be 14, but I'll always have to let C be the longest side, which is 17. So in this case here, I have to use the Pythagorean formula to determine whether those lengths will represent the sides of a right triangle. Now I'm letting A be 11 and B be 14, so it'll be 11 squared plus 14 squared. That must be equal to the length of that third side, which is 17, or the longest side. Okay, so 11 squared is 121, plus 14 squared, that's 196, and it must equal to 17 squared, or 289. So 121 plus 196 must equal to 289. Now when I add this up, it's going to give me 317, which does not equal to 289. Okay? So here, these numbers, 11, 14, and 17, would not represent the lengths of the sides of a right triangle. Okay, problem number 3. A 19-foot ladder is placed against a vertical wall of a building, with the bottom of the ladder standing on level ground 9 feet from the base of the building. How high up the wall does the ladder reach? Okay, now sometimes it would help to just draw a figure. Okay, let's say we have a wall like this one right here. And in this case here, here's our ladder that goes like this. And it's a 19-foot ladder. And it's on a level ground. Here's a level ground that's 9 feet from the base of the building. Here's the base of the building at the bottom, and that ladder is 9 feet from that base. Now we want to know how high up the wall does that ladder reach. That's this length right here, which I'm going to call B. Okay. So in this case, to find out what B is, we need to use the Pythagorean Theorem, which is c squared is equal to a squared plus b squared. The c is our hypotenuse, which is 19, so it'll be 19 squared, and that's equal to a, I'm letting that be 9, so it'll be 9 squared plus b squared. So in this case here, if I do 19 squared, that's going to be 361. And that's equal to 9 squared is 81 plus b squared. Now if you subtract 81 from both sides, we're going to get, let's see, 280, which is equal to b squared. Okay, and our problem does say round to the nearest hundred, so if we take the square root of 280, you're going to end up getting 16.73. And in this case, it'll be 16.73 feet. So in this case here, the ladder reaches 16.73 feet up the wall for this particular problem. Okay. All right, here's another problem similar to that. Find the height of the tree shown at the right. Okay, now here we're trying to find the height, so I'm going to let B be the height. And then I'm still going to use the Pythagorean Theorem just like I did in the other problem, which is in this case c squared is equal to a squared plus b squared. And in this case, our c is the hypotenuse, that's 30 feet. So that's 30 squared is equal to a, which is 19 feet. So that'd be 19 squared plus b squared. And then b be the height of that tree that I'm trying to find. So in this case here, 30 squared is 900, and that's equal to 19 squared, that's 361, plus b squared. Now I'm going to subtract 361 on both sides to get b squared is equal to, that's going to be 539. And then to find out what b is, you take the square root of 539. And we're going to round to the nearest tenth here to get 23.2. Okay, so the height of that tree is going to be approximately 23.2 feet. Okay, problem number 5 is finding the distance between the pair of points. Here we got negative 513 and negative 1212. There is a formula for finding the distance of any 2 points, which is going to be d is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, x2 minus x1 are your x-coordinates, negative 12 minus negative 5. And all of this is under the square root symbol. Plus y2 minus y1, that's 12 minus 13. And that 2 is squared. Now, when you find the distance, negative 12 minus the negative 5 would be negative 7. And that's squared. Plus 12 minus 13 is negative 1, and that's squared. Now, negative 7 and u squared will be 49. Plus negative 1 squared will be 1. So now you got the square root of 49 plus 1, which is the square root of 50. And the square root of 50 on the calculator would be 7.071, rounded to the nearest thousand. So that distance would be 7.071, rounded to the nearest thousand.